What's up guys, it's Simon Fields and today's video is on AQA level chemistry group 7 halogens question paper from PMT. This question about chlorine. Chlorine has a low boiling point because the forces between molecules are weak. Explain how these forces arise. Can you guys hear me? Yes you can, between molecules of chlorine. Random movement of electrons in one molecule induces a temporary dipole in another molecule. Temporary dipole attract, hence temporary attraction between delta positive and delta negative. Give an equation for the reaction of chlorine and water and give a reason why chlorine is added to drinking water. So the equation Cl2 plus H2O, reversible reaction HCl plus HClO. Cl2 plus HO, HCl plus HClO, and the reason it's added, chlorine is added to drinking water, is because it kills bacteria. Given equation, chlorine reacting with cold aqueous sodium hydroxide plus 2 NaOH, NaCl plus NaClO plus H2O. Cl2 plus 2 NaOH are NaCl plus NaClO plus H2O. Which pair of solutions when mixed reacts to form a dark brown solution? I see dark brown and I'm thinking of iodine, so D, because you can see the iodide there. Some solid sodium halides are reactive with concentrated ferric acid. Which solid sodium halide does not produce a sulfur containing gas among the products? Does not. NaBr, I know this definitely does. I'm not sure about this one. I don't think that's the equation you need to memorize. But I know NaCl doesn't, because you need to know that equation as well. It's NaCl plus H2SO4 to form NaHSO4 plus HCl. HCl is a toxic gas, but it's not a sulfur containing gas. So yeah, the answer is A. Given the equation for reacting solid sodium bromide with concentrated ferric acid to form bromine. So 2H2SO4 plus 2 NaBr, Na2SO4 plus SO2 plus Br2 plus 2H2O. And one observation made, brown fumes. I don't think any question has been application so far. Okay. Solutions thought to contain chlorides and iodines is tested. This. Give a reason for use of each reagent. Explain the observations. So this, explain the observations, and then give ionic equations for any reactions. So why is dilute nitric acid added? Well, HNO3 removes carbonate ions that may give other precipitates with silver nitrate solution. Silver nitrate solution produces precipitates with chloride slash iodide slash with halide. And then the ionic equations, well, obviously you're going to have the Ag plus aqueous plus Cl minus aqueous, AgCl solid. And then why is ammonia added to the mixture? Because ammonia dissolves silver chloride. So NH3 dissolves AgCl, and then the equation, well, obviously AgCl plus 2NH3 to form AgNH32 plus Cl minus. Give me the equation for reaction of chlorine with water. So the equation Cl2 plus H2O, HCl plus HClO. A resin is treated with chlorine to kill bacteria. And then this one is a bit of a new kind of question, I guess. Why is it added even though it is toxic? Is because it's used only used in small quantities. So to kill bacteria, only small quantities, and then that's the equation you just have to memorize. Okay, give a half equation of conversion iodide and all of this. Okay, this one is your application, right? How well have you know the skill of constructing half equations and all of that? So solid sodium iodide give a half equation iodide ions I minus to iodine. So I need a 2 here, and then I need a 2 negatively charged electrons here. Sulfuric acid, H2SO4, to sulfur. Well, I need to add. The only way you can add hydrogens and oxygens is by adding water molecules. But how many water molecules? Well, I'm going to add 4, because I want 4 oxygens. Then I've got 8 hydrogens, so I need to add 6 H pluses here, and then I need to add 6 negatively charged electrons to balance out the overall charge. And then the overall equation, well, there's a 2 here, so I need to times this one by 3, so I get 6I minus arrow 3I2 plus 6E minus, and that is still equation 1. I've just multiplied it by 3. And then what you should know is that the negatively charged electrons cancel out with 6 electrons, so you get then, let me zoom out a bit, you get 6I minus plus 6H plus H2SO4 arrow 3I2 plus sulfur plus 4H2O. 6I minus plus 6H plus H2S4 3I2 plus sulfur plus 4H2O, H2S4 plus 6H plus 6E minus S plus 4H2O. There you go. Other sulfur containing reduction product, sulfur dioxide, or you could talk about hydrogen sulfide. Sulfur dioxide is more obvious, so I would use hydrogen sulfide in the past paper question to get you used to that, but in a real exam you use sulfur dioxide. Suggest when excess is used of what? Of silver nitrate, excess of aqueous silver nitrate solution. Well, the reason we add silver nitrate is to ensure all the halide ions are removed from the solution. So the excess is to ensure all the halide ions are removed from the solution to ensure all the halide ions precipitate out of the solution. Calculate amount of moles of silver iodide obtained, that's the MR, and it is a 1 marker. Well, the mass obtained is that, so I need to convert it into grams, so it's 0.315 grams, and then I know moles equals mass 0.315 over MR 4.8 0.215 over 234.8, and you get 1.34 times by 10 to the power minus 3 moles. Calculate using your answer the mass in grams of sodium iodide in a mixture using answer to part D. Well, my answer to part D was the amount of silver iodide. Now, silver iodide and the sodium iodide. Well, I want to work out the mass of something. What was the mass of MR? Mass equals the moles, which obviously I'm going to use from part D. It literally tells me to. So 1.34 times by 10 to the power minus 3 times by the MR of sodium iodide, 149.9. 1.34 times by 10 to the power minus 3 times by 149.9. 0.201. And then it says, use your answer to part E, the percentage by mass of sodium chloride in a mixture. Okay, now I need to actually read a bit of content. It says, student completes experiment determined by percentage by mass of sodium chloride in a mixture of sodium chloride and sodium iodide. Okay, so that's all I need to know. I've got sodium iodide. I want to find the percentage by mass of sodium chloride. So first thing I need to do is find out the mass of sodium chloride, which is 0.600. Yeah, 0.600. Well, I guess I convert that to milligrams, so I do 600 minus 201. Yeah, I might as well just do it like this. Then I get 399, and then that's the mass of sodium chloride in milligrams. And therefore, the percentage by mass is 399 over 600. It is a percentage, so I times by 100. I get 67% or 66.5. I'll say 67%. It says it allows 66.5 to 68.3, so that's fine. So yep, the mass 0.210, and then you get that. Which equation shows a redox reaction that does not occur? No, sorry. Which property increases down group 2, down group 7? Okay. Okay. This one's a bit tricky. Well, obviously, if you've memorized the trends beforehand, I've forgotten them. I can't lie. Increases down group 7. It's not going to be electronegativity. I know that for a fact because. Wait, let me get the periodic table out. Maybe that's a better idea. Yeah, it's not going to be that because I know I've memorized this fact. Fluorine, which you should as well, is the most electronegative element. Is the most electronegative element, and fluorine is at the top of group 7, so it's not going to be that. First ionization energy, no. Boiling point, yeah, I think it's boiling. It's got to be boiling point. Boiling point increases down group 7. Question 7. Which equation shows a redox reaction that does not occur? Now, what you need to spot is, in order for this kind of stuff to occur, bromine and potassium iodide, right? So you need to look. Bromine and iodine. Iodine is further down the group than bromine, so therefore the reaction can occur. Chlorine and iodine. Iodine is further down group 7 than chlorine, so it can occur. Bromine and chlorine. Bromine is further down the group 7 than chlorine, so it can occur. Iodine and bromine. Well, what this is saying that bromine displaces iodine, which is, that cannot be true because iodine is further down the group 7 than bromine. So it actually should be iodine displacing bromine, so therefore that cannot occur. This question is about sodium halide. It was sodium nitrate solution, add sodium fluoride solution. I always like this one. You don't say nothing, you have to say no visible change. Stay one observation: solid sodium chloride reacts to constitute sulfuric acid. Observation: missed white fumes of gas. White fumes of gas. Role of chloride ions in this reaction. Well, the role is the base, and then the equation, well, NaCl plus H2SO4 NaHSO4 plus HCl. White fumes of gas, NaCl plus H2SO4 or NaHSO4 plus HCl, base / proton acceptor. Give the equation for the redox reaction between solid sodium bromide and constitute sulfuric acid. Explain use oxidation state. Why this redox reaction? So again, this is an equation. This is an equation you need to know. So 2 NaBr plus 2 H2SO4 Na2SO4, and you guys, you cannot not memorize these equations, because if you do that, you're limiting yourself to not an A. I think if you don't memorize any equations, you're limiting yourself to a B maximum if you get everything else right. An explanation, well, you just need to talk about oxidation state. Well, bromine changes oxidation state. Well, that's not enough. Some mark schemes, yeah, that's enough, but try to fit every kind of mark scheme. So bromine change oxidation state from what? Well, in this case, I don't care about the moles, it's -1. In this case, it's 0. So we'll change oxidation from -1 to 0, and therefore it oxidized. And you need those two key points. The oxidation states it changes from to, and what is it? It's been oxidized or reduced. Say was an aqueous chlorine added to sodium bromide solution. Chlorine added to sodium bromide solution. Yellow solution. An equation, sodium bromide solution. That's going to be Cl2 plus 2Br minus. And you should know this, 2Cl minus plus Br2. So you have to be very aware of this. It says solution, so that I'm talking about obviously ions, and then therefore, well, it tells me right here it's the ionic equation anyway, so that's fine. Which shows the major product form when chlorine reacts with cold dilute aqueous sodium hydroxide. Chlorine, reacts with cold dilute aqueous sodium hydroxide, NaOH. Well, I've already memorized this formula, and you guys kind of have to memorize this formula. This equation, sorry, not formula, equation, and then you know those are your products. So which are the major products? Sodium chloride only, no. Sodium chlorate only, no. Sodium chloride and sodium chlorate, yes. That and that. Question 10, which is the best oxidizing agent? Now, what does oxidizing agent even mean? So what is an oxidizing agent? Is it electron acceptor or electron donor? So an oxidizing agent is an electron acceptor. So we cross out this and this because those want to donate the electrons, negatively charged. So method fluorine and iodine. Therefore, it's going to be fluorine. Why is fluorine a better oxidizing agent than iodine? Now, when I think about fluorine, I obviously know the fact it's the most electronegative element. Yeah, if you just know electronegativity, most electronegative, it pulls the electrons, ability to attract a pair of electrons, and therefore it's going to be the best electron acceptor, best oxidizing agent. Which statement is correct by reaction involving halide? Sodium chloride forms chlorine when added to concentrated sulfuric acid. Sodium chloride plus H2SO4 forms chlorine. No, it doesn't. It forms NaHS4 plus HCl. Sodium chloride forms chlorine when added to bromine. Sodium chloride forms chlorine when added to bromine. No. Sodium bromide forms bromine when added to concentrated sulfuric acid. Yes. Which statement is not correct about the trends in properties of the hydrogen halos from HCl to HI? The boiling point is decreased, the bond dissociation with the energy of HX decreases, the polarity of the HX bond decreases, they are more easily oxidized in aqueous solutions. Which one is not correct? A. The boiling points decrease. If I'm going from in group 7, Cl to iodine, I know in group 7 which property increased down group 7? Boiling point increases down group 7. So therefore the boiling points decreases is not correct. This question about group 7 compounds, sodium chloride reacts with concentrated sulfuric acid, NaCl plus H2SO4 to form NaHSO4 plus HCl. The role of sulfuric acid in this reaction is a base. As you know, it's a proton donor. It's a proton donor. Proton donor. Fumed sulfur dioxide are formed when sodium bromide reacts with concentrated sulfuric acid. For this reaction, give an equation, given what other observations state the role of sulfuric acid. So give an equation for this reaction. Now I can't use NaBr plus H2SO4 to form NaHSO4 plus HBr, because it says in the question when this fumed sulfur dioxide are formed. I ain't forming sulfur dioxide in this case. So the equation is 2NaBr plus H2SO4 plus 2H2SO4 to form Na2SO4 plus SO2 plus Br2 plus 2H2O. Observation, I'm going to form bromine, so a brown gas, and the role of sulfuric acid in this equation is oxidizing agent. Oxidizing agent, and what is an oxidizing agent? It is an electron acceptor. Really important to learn that / electron acceptor, because once you've learned one of them, you know the other one. Therefore, you know reducing agent is electron donor. Give the oxidation state of chlorine in this and this. Sodium chlorine oxide hot equals sodium hydroxide. Okay, show the equation. Give the oxidation state of chlorine NaClO3 and NaCl. Okay, well in this case, oxygen is minus 2 times by 3 minus 6 plus the sodium, which is 1, which is minus 5, and therefore chlorine must have an oxidation state of plus 5 to get an overall charge of 0. In this case, that's plus 1, therefore that's got to be minus 1. Plus 5 and minus 1. So in terms of redox, what happens to chlorine reaction part C? Chlorine is oxidized and reduced. And can you guys remember what that's called? Disproportionation reaction. And I think it's not necessarily important. It's important to familiarize yourself with that. So in the exam it says this is an example of disproportionation reaction. Why? Well, because something's oxidized and reduced. But if you don't know what disproportionation means, you're not going to be able to access the question. Okay. Give the formulas of D, E, and F. Give an equation show the formation of E. Give an equation show the conversion of D and G. Okay. So it says solution Y contains two different negative ions. Negative ions meaning anions. To a sample of solution Y in a test tube, a student adds silver nitrate solution. Silver nitrate solution. What is the formula of that? Ag, what? NO3, silver nitrate solution. Then an excess of dilute nitric acid, HNO3. That's obviously to remove carbonate ions which might interfere with the test, produce precipitates out of the solution. And then an excess of concentrated ammonia solution, NH3. The observations after each addition are recorded in a table. Silver nitrate solution, cream precipitate containing compound D and compound E. Excess dilute nitric acid, cream precipitate of D, bubbles of gas F. X-ray concentrated ammonia solution, colorless solution containing complex ion G. Okay, formulas of D, E, and F. Well, F bubbles immediately. I don't need to know anything. I know it's carbon dioxide gas. What else can it be? It's going to be carbon dioxide gas. Now with D and E, cream precipitate containing compound D and compound E with silver nitrate solution. So cream precipitate. Sodium bromide. No, sorry, silver bromide. And then the formula of E, compound E, Ag2CO3. And an equation to form E, Ag2CO3, 2Ag plus, so CO3 2 minus, and that's how you form Ag2CO3. But let me just have a quick look at this. And then equation conversion of D into G, complex ion G. We've got DAGBr. I'm adding ammonia. And what am I going to form? I'm going to form AgNH NH3 plus, that's obviously, that's going to be positively charged, and that's going to be Br minus, which is negatively charged. Anything else missing? Obviously I need a 2 here and 2 here. Just say excess concentrated in the solution. Question 14. Separate unlabeled solid samples of 3 anhydrous sodium compounds are provided for student identifiers. Compounds are known to be sodium carbonate, sodium fluoride, sodium chloride. But it's not known which sample is which. Outline a logical sequence of test tube reactions that a student could carry out to identify each of these compounds, identify observations a student would expect to make, give the equation including states and any reactions that would take place. Okay, so stage 1, my suggested test: add hydrochloric acid to all 3 compounds, add water, add silver nitrate solution. That's all I need to add, right? Stage 2, my expected observations: sodium carbonate will fizz with acid. Sodium chloride gives a precipitate. Why just sodium carbonate? Because it's got carbonate ions, so that's why it will fizz with the acid. Carboxylic acid. Sodium chloride gives a white precipitate with silver nitrate, obviously. Sodium fluoride shows no visible change. And then stage three, my equations. Well, what? Equations for what? For any reactions that would take place. Would NaF take place? No. So the only things that can take place Na2CO3 and NaCl. So Na2CO3 plus fills with acid. I say hydrochloric acid, but it should be silver nitrate. HNO3, right? So plus HNO3, I'm going to form NaNO3. I'm also going to form CO2. I'm also going to form H2O. And therefore I need a 2 here, because I've got 2 sodiums there, I need 2 here. And I also need a 2 here, so I've got 2 NO3s on both sides. And then the other one, which is very simple, sodium chloride plus AgNO3 plus sodium chloride. Well, I'm just going to form AgCl3 plus NaNO3. Which statement is correct about the reaction between concentrated sulfuric acid and solid sodium bromide? Bromide ions are reduced, hydrogen bromide sulfur formed, sulfuric acid acts as an oxidizing agent. Does it? Yes, it does. How do I know that? Because we just did the previous question on. We did went through it. Where was it? Where was the question? Yeah, here it was. Sodium bromide constitutes sulfuric acid. State the role of sulfuric acid. The role of sulfuric acid oxidizing agent. Sulfuric acid acts as oxidizing agent. So just by memorizing that, I can spot immediately. Which is the best technique to remove the silver chloride that forms when aqueous solutions of silver nitrate and sodium chloride react? So I've got silver chloride, NaCl, to remove the silver chloride that forms when aqueous with silver nitrate and sodium chloride. So sodium chloride, NaCl, plus silver nitrate, AgNO3. Well, I'm going to form AgCl plus NaNO3. To remove this, well, distillation is based on no. Refluxing, no. It's going to be filtration, isn't it? Definitely filtration. I think that's more of just a logical kind of question. Which statement about acetine is correct? Acetine has a greater electronegativity than bromine. Well, let's have a look. Where's bromine? Where's acetine? Acetine is further down the group than bromine. Acetine has a greater boiling point than bromine. Boom, that's the answer. That is the answer. Who is it big? Group, as you go down group 7, boiling points. As you go down group 7, the boiling points increase. Which species not produced by redox reaction with solid sodium iodide constitutes sulfuric acid? Sodium iodide plus H2SO4, but it's said by redox reaction of that. You definitely form this. I know you definitely form this. Na2SO4. I don't think you form. I don't think you form that Na2SO4. Sulfur, yes. Sulfur dioxide, yes. This is A. Question 19. A student was given a 50-gram sample of solid silver chloride contaminated with solid silver carbonate. Alhamdulillah. The student suggested the following method to obtain the maximum amount of pure, dry silver chloride from the sample. Tip the solid into a boiling tube, add dilute nitric acid, allow the remaining solid to settle, decant off the liquid, leave the sample to dry on the shelf. Identify any faults or omissions in the method suggested by students, suggest improvements to the method using commonly available laboratory experiment equipment. The following chemicals are also available: distilled water, dilute solution, this, and this. Okay, so first things first, um, into a boiling tube. But I'm adding 50 grams. And it says tip the solid into a boiling tube. Well, yeah, the first part is a bit of, have you read the question properly? Properly. Stage 1, boiling tube is likely to be small for 50 grams of solid. Hence, we use a large beaker instead. Stage 2, silver nitrate will form soluble. Nitric acid will form soluble AgNO3. Because we're pouring silver chloride into that, we will form AgNO3. Yes, we will form that. And what do we want? Well, we want calculate maximum of pure dry silver chloride. So max of silver chloride cannot be obtained because we're going to form silver nitrate. So we need to use HCl instead. Stage 3. Well, what does decanting mean? I don't think this. I think it's an old spec question because this decanting. I've never heard of that ever. It means the solid is wet. It means the solid is wet / contaminated with silver nitrate. So instead of leaving the sample to dry on the shelf, we need to, instead of leaving the sample to dry on the shelf, use filter and then wash with distilled water. Question 20, this question about elements of group 7 periodic table. And the compounds bromine, strontium chloride, and iodine monochloride all have similar MR values. Suggest with reason to order melting points for these three substances. 6 marks. Bromine, strontium chloride, and iodine monochloride. Well, I know bromine has van der Waals forces, so obviously that's it. Iodine monochloride. Well, strontium chloride has strong ionic bonds. Also has a giant lattice, so many strong bonds to overcome. Iodine monochloride has dipole forces between molecules, and these are obviously weaker than ionic bonds. And then bromine has van der Waals forces between molecules, and these are the weakest forces, the weakest out of the three. And then the order of the melting points, well, therefore I've said strontium chloride has strong ionic bonds, so it's going to be strontium chloride, That's got a melting point greater than iodine monochloride, and iodine monochloride has a melting point greater than bromine. Yep. One equation for action of chlorine with cold water, Cl2 plus H2O. Reverse reaction, HCl plus HClO. Consider a reason why chlorine is added to drinking water and suggests the disadvantage of treating this. Well, it kills bacteria, that's why it's added to drinking water. It's bacteria. And the disadvantage of treating water in this way. I've never seen this kind of question before. Disadvantage. Okay, a disadvantage. Can react with organic compounds. Organic compounds to produce harmful substances. Can react with organic compounds to produce harmful substances. One equation for this reaction, bromine with phosphorus. Bromine plus phosphorus, which is P4, to form phosphorus tribromide. Phosphorus P tribromide 3 bromine. I need 4 here because I've got 4 there, and because I've got 12 there, I need a 6 here. And then suggest the bond angle. 107 degrees. Phosphorus pentabromide solid state consists of this, and this. Draw the shape of this and suggest its bond angle. Well, it's going to be 109.5 degrees. It's going to be tetrahedral. And if we have a look at it, BR. No, it's not BR. Yeah, it is BR. BR. And that's positive charge. Yeah, that's tetrahedral, 109.5 degrees. Which equation represents a reaction that does take place? Okay. That does take place. Chlorine and iodine. Well, iodine is further down the group than chlorine, so it will displace it. So yeah, that is the correct answer. But if I look at, let me get rid of that. Let's have a look at the rest of them first. So bromine and iodine. Well, bromine and chlorine. Well, bromine is further down the group than chlorine. Chlorine is higher up the group than bromine. So chlorine cannot displace bromine. No, sorry. Bromine. I think I'm just confusing myself at this point. Bromine. No, yeah. Chlorine cannot displace bromine. A reaction that does take place. NaCl plus H2O. No, you're going to form NaCl. No, NaCl plus H2O, HCl plus NaOH. So you're saying acid plus water. I'm forming an acid plus base. And nope. And then this one. No, but yeah, as long as you can spot that, then you start. It's A. Which species is the best oxidizing agent? So what does oxidizing agent even mean? Oxidizing agent means electron acceptor. So I can cross out the negative ions. Obviously, then they don't want to accept electrons. They want to donate electrons. They want to be electron donor. They want to be a reducing agent, not oxidizing agent. And left with chlorine and bromine. Well, bromine is further down the group than chlorine. So bromine is less electronegative. So chlorine is the answer because electronegativity increases up group 7. So A is the correct answer. And you might be wondering, Iman, how does that relate? Well, if chlorine is more electronegative, is more electronegative, negative than bromine. What does that even mean? Electronegativity is the ability of an atom to attract a pair of electrons in a covalent bond. So it can attract the electrons very strongly, so therefore it can accept electrons easily, and therefore it's the best oxidizing agent, which is electron acceptor. Sodium bromide reacts constantly for gas in a different way from sodium chloride. Write the equation for reaction and explain why bromide ions react differently with chloride ions. So this one is asking for this equation, 2NaBr plus 2H2SO4, 2H2SO4 to form Na2SO4, Na2SO4 plus Br2 plus SO2 plus 2H2O. Why it reacts differently than chloride ions? Well, number one, Br minus ions are bigger than Cl minus ions, therefore more easily oxidize. But Iman, what does more easily oxidize even mean? Oxidation is the loss of electrons. So they Br, so therefore loses electrons more easily, and that makes a lot of sense. Compared if you say oxidize, but if you don't know what that even means, then you're not going to lose electrons more easily. So always try to think in terms of the fundamental particles: protons, electrons, neutrons. Well, Br minus ions are bigger, so therefore more easily oxidized. But what does that even mean in terms of fundamental particles? It loses electrons more easily. A colorless solution contains a mixture of sodium chloride and sodium bromide using aqueous silver nitrate and your reagents of your choice. Develop a procedure to prevent pure sample of sodium bromide from this mixture. Explain each step and procedure. Illustrate your examples with equations where appropriate. Stage 1. Add silver nitrate. Add water /cement into a solution. And then the equations. You could also say add acid. So HCl, HNO3, whatever you want to say. By the way, you've got sodium chloride and sodium bromide, AgNO3 plus NaCl, AgNO3 plus NaBr, AgCl plus NaNO3, AgBr plus NaNO3. And then stage 2, add excess of dilute ammonia, so dilute NH3 to the mixture of precipitates. And what you notice is that the silver chloride precipitate dissolves, and it's the only one that dissolves, I'm pretty sure. So then the equation is going to be your silver chloride plus 2NH3 to form Ag bracket NH3 2 plus Cl minus. And then stage 3, the filtration and the removing of the purification. So stage 3, filter off the remaining silver bromide precipitate, wash to remove soluble compounds, and dry to remove water. And there we go. And then final part, ionic equation for reaction between chlorine and cold dilute aqueous dilute sodium hydroxide. Now a lot of students, including myself, would just jump straight into this question. Just thinking Cl2 plus 2NaOH, recalling the equation from memory, NaCl plus NaClO plus H2O. But it says ionic equation, and that's really important. Well, if it's ionic equation, it's going to be, instead of that, it's going to be Cl2 plus OH minus, and you're going to form ClO minus plus Cl minus plus H2O. I don't care about the sodium because the sodium is a solid. I don't care about solids. I only care about, it's called ionic equation, writing about the ions. So Cl2 plus OH minus ClO minus plus Cl minus plus H2O. And the reason I've done this is because now you can compare them. You copy and paste on your original equation you memorize, and then because it says ionic equation, you just want the ions involved. That definitely could be an exam question. But yeah, that's what you have to remove. Just remove the sodium and add the negative charges where appropriate. Give the oxidation of chlorine each of the chlorine containing ions. So in ClO minus, chlorine has an oxidation state of what? Plus one, because oxygen minus 2 plus 1 to get overcharged minus 1, whereas in Cl minus, obviously chlorine has an oxidation state of minus 1. So yeah, that's really interesting. Ionic equation, just do copy and paste this equation, memorize, and remove the sodium, add the negative charges. And that is the end of this question paper.